guys, this video is on learning target 9, simplify radical expressions using properties of roots. Alright, so we've already looked at some square roots. We're going to take a closer look to what you can do with them. There are 3 properties we're going to use today. One is the addition of radical expressions, or the addition of numbers with square roots is basically how we're going to look at it. So if we have a combination of a term here that is a combination of what would usually be an integer or a rational number plus or multiplied right here a irrational number. So this might look like 3 square roots of 5. Okay, and then we have, so that 3 would be a, square root of 5 would be, or 5 would be x. And then we have another number here, let's say 2 square roots of 5. So if the number under the square root is the same, then what we can do there, and those 2 terms are added together, we can add the 3 and the 2, and then we can leave the square root of 5 here. So for any numbers a, b, and x, this will hold true. In the same way, if those terms are multiplied, okay, if we have a times the square root of x times b times the square root of y, so notice here we have 2 different numbers under the square root. We can take and we can multiply the numbers outside the square root, as well as we can multiply the numbers inside the square root. Okay, so multiplication is a little different. Addition, we could only add the numbers outside the square root, and we can only do that when our number under the square root is the same. That's kind of like terms. You have to have the same number under the square root there for addition. Multiplication, you can manipulate under the square root as well as in front of the square root. And the same for division. You can manipulate under that square root here for division. Alright, so, and then with division, we need x to be greater than or equal to 0, and then we need y to be greater than 0. Why do you think this is? Why can't y be 0? Because we can't divide by 0. And that's a rule you guys should know. So let's look at a few examples. Here we have addition. Okay, so we're adding 2 radical expressions. We have 2 square roots of 3 and 5 square roots of 3. Notice the number under the square root is the same in both expressions, so we're good there. We can use our property of addition. So that means we can take 2 plus 5 and then just keep that square root of 3. Alright, so here we're going to have 7 square roots of 3 is our final answer. And since we don't know a whole number that is the square root of 3, we leave it as that radical expression. Alright, so this is our answer there. Over here we're multiplying, and we're multiplying 3 square roots of 5 and 2 square roots of 7. Alright, so here our multiplication property tells us that we can take the numbers outside of the square root and multiply those. So we can take 3 times 2, and then we can also take the square root of 5 times the square root of 7. So that's going to be 3 times 2 is 6, and we're going to have the square root of 5 times 7. I'm just going to write that one more way. These 2 are equivalent here, and that's going to be 6 square roots of 35. Alright, and again, that's as simplified as that can get, so that's our answer there. Moving on to a division problem, we have the square root of 15 divided by the square root of 3. We can take and make that operation under one big square root, so that's going to be the square root of 15 divided by 3. 15 divided by 3, 3 goes into both of those. It goes into 15 5 times and 3 once. So we're going to have the square root of 5, which we know from the video before is an irrational number, and that's as simplified as we can get. Over here, we're going to distribute. So you guys saw a video earlier in this unit with Miss Atwood talking about how we distribute when working with expressions. We're going to do that same thing here with kind of the 2 swoops, bringing this square root of 3 into these parentheses here. So our first swoop, or our first bout of multiplication, is going to be 5 times the square root of 2 times the square root of 3. Alright, and we know from our properties of multiplication that we can do that multiplication under that square root, so that's going to be 5 square roots of 6. 2 times 3 is 6, and so that cannot be simplified anymore. our addition sign comes down. So we're adding to that. Our second swoop is going to be 3 square roots of 3 times the square root of 3. All right, so if we write that out, I'll just expand this here. That's going to be 3 times the square root of 3 times 3, or 3 times the square root of 9. Now, you guys probably recognize the square root of 9 is what? 3. So that's going to be 3 times 3, and 3 times 3 is 9. So this expression actually simplified down into a rational number. So we have 5 square roots of 6 plus 9. And actually, you'll see this most commonly written with the rational number in front. So I'm just going to switch. That's 9 plus 5 square roots of 6. All right? And that would be our simplified answer there. Okay? And notice we cannot add those together because we don't have a square root of 6 with that 9. So before class, we would like you to create and solve 3 problems, one for each operation with radicals. So you need to make an addition problem, a multiplication problem, and a division problem, and bring those to class with you.